Hello, this is the Introduction to Biostatistics using R. We're in Chapter 2, Part 2, and we're going to look at group data and the frequency distribution associated. Group data is a great way to summarize a variable and, to know how spread out it is, how, if it's clustered in certain categories. And sometimes a variable is age, it's continuous, so it doesn't really have a convenient interval, so we have to make up intervals. And whenever possible, use like clinically meaningful intervals. So maybe we group age into, young, middle, and older patients, or we group them every 10 years or every 20 years, whatever's clinically meaningful to your study. But we're going to look at the table functions and several of its extensions. We're going to use the motor trend cars data set. It's built into every R distribution. And so we're not really going to analyze it. We're just going to use the table function to summarize a few of these. The summary function on a data frame takes every variable and creates 6 statistics based upon that variable. So miles per gallon, cylinder, displacement, HP, etc., etc. So the table function is, in my opinion, it's really nice for 2 variables. If we want to table 2 variables or cross-tabulate, now notice that I'm doing this within the motor trend cars data frame, and that way that I can just simply access the variable names when I create a table. So cylinder, which is the number of cylinders in your engine, is along this side, and gear, that's the number of forward gears in your car. So 3, 4, or 5. And then this is the distribution. So one car was 4 cylinders, only used 3 forward gears. 8 4-cylinder cars had 4 forward gears, etc. And so this is pretty nice. It's a simple tabulation, but notice there's no proportions in here. And so there's a function. Oh, also we stored these results in TBL table. So this is stored there. Now notice these outside brackets here. When you put a result or parentheses around the outside, what that does is it performs the procedure. So it creates this table, stores it here, but the outside bracket says not only do that, display it. So you get a display of what you just performed. It's not working. So here, proportions is a way to create proportions from your table. So that has to be you've had to use table. Now, technically, we could just put that function right there, but then I think the readability isn't quite as nice. So we use proportions, and we want it over margin 1. So that means this is margin 1. So when we go this way, these add up to 1. So it's 100%. We're proportionate this way. But if you want your proportion over the columns, then we just say over column 2. And then when you add this way, it's the proportion of within each column. Now, notice in this table, there's no row totals or sums, or no column sums. And so we can add that. There's an add margins function, which is you have to supply the table, and then we want to add the margin 1 table. So this is margin 1, and we're going to put a sum there, and it sums it by column. Now, often you want to do it across both margins. So we want to add totals on each margin. Now, of course, this could be saved and then used later into, some variable. If we only want, say, these right here, there's a function called margin table. So you have to supply your table, and we want it over margin 1, and it only supplies the totals. Now, there's also a function called row sum it might, row sums. I think there's an S, but you'll have to double check that sums across rows and provides the same thing. There's also a column sums too. So you don't have to use this function. I don't know which one I like better, but both are fine. And so, but if we wanted these margin totals, then we want the margin of the table, margin 2, which would provide these here. Now, the table function, when you're using 3 or more variables, in my opinion, is not very friendly. and so what it is the table function. Again, we're using the Motor Trend Cars data set, and that's so we can just access the variable names by name. We don't have to go MT cars $sign CL1 and then comma and then repeat it. And so this is just kind of an easier, cleaner way to do it. What it does is it creates a 2x2 table conditioned on the values for this. So VS, that stands, it's about the engine. Are the pistons V-shaped or straight? And it's a 0, 1. And I don't know if one is straight or one is V-shaped, but I'd have to look. But what it does, so for each value, then it creates a 2x2 table. And then it goes to the next value of VS, which is 1, and then it creates a 2x2 table. And I guess that can be useful. I just haven't used it much. Although I guess I've saved it into a variable and then used it in later analyses, but I have, for just displaying it, I don't think it's very nice. There's a better function. It's called F table, and the F stands for flat. This is called a flat table. What it does is however many variables you have here, the last one is the columns. And then these two, they're created. So cylinders are 4, 6, and 8. Gears are 3, 4, and 5 within each of those. And then the VS is across the column, and then this is a summary. So we had one car that had 4 cylinders, 3 forward gears, and had a straight set of pistons instead of the V-shaped. I'm assuming the 1 means that. There's none here. But the beauty of this flat table is you can create very nice looking 4-way tables. So the AM is automatic transmission or manual. And again, I don't know what the 1 and 0 mean. So I'm going to assume the 1 is a manual. So this AM is the column, and then these 3 create the rows, but it's by cylinder, gear, and then V-shaped or straight-shaped. And this is it. Now, the downside of these, when you start getting to 4 and 5 and more way tables, there's the curse of dimensionality. And so your data becomes so sparse that there's just no data that can fit all these combinations. And so a convenient way to create a 4-way table, notice that I saved it here. And of course I printed it out with those parentheses, but I saved it because there's a print function that says, hey, if it's a 0, just put a little dot there. or you could put whatever character you want to use there. But then when you see this table, you quickly can just isolate, the combinations that create a value. Okay. Now here's the aggregate, and this is also another way to summarize the data over groups. Remember, that's our goal in this section. So with this is, we're going to explore aggregate, and hopefully you'll be an expert by the end. So with the Motor Trend Cars data set, aggregate means, bring it together. So this is our data, the miles per gallon. It's the variable within here. And this is our group variable. So cylinder has, 4, 6, and 8 cylinders. So this is the data that we want to analyze by this group variable. And we're going to use this function. And we're going to put in several different options for here. But length just counts the number in your vector. So there's 11 cars. There are 11 observations that have that we have miles per gallon. In a 4-cylinder car, there's 11 observations. For 6 cylinders, in miles per gallon, there's 7. So we're really not summarizing miles per gallon, except for how many observations in miles per gallon do we have for each cylinder. So it's 11, 7, and 14. Now, a couple things here is, I don't know what that is. So here's the downside of length, and I've seen people make this mistake. It counts the length of the vector. So if you have missing observations, that missing observation takes a spot in your data vector. But you don't analyze missing values. So a better function than length, if you just want to count the number of observations you're going to analyze. So this is the same function, the same command up here, but instead of us applying the length function, we create our own function, and we count how many are non-missing. So this creates a 0, 1 vector. Is it missing? Yes or no? This negates it. So if it's there, it's a 1, 0 otherwise, and we sum it. And then in this data set, there's no missing value, so we get the same thing. So in this command up here, we could have said function equal function, and then x, and then we'd have to put the length of x. So we could have put this in there, but length is it's a pre-specified function, so you don't have to do it. But what it does is the data that it's supplying there, it's supplying all the miles per gallon values for this category, and then applying that function. Then it goes to this one, and then this one, and that's what we get here. So now if we want to find the mean, or the miles per gallon per cylinder, engine cylinder, number of cylinders. So we say aggregate, this is our data. We're going to group it by this, and we want the mean. So this is it. And if you look at the data, it makes sense that if you have a 4-cylinder car, you're getting 26 miles per gallon. If you have a 6-cylinder car, you're getting 19 miles per gallon. And if you have an 8-cylinder, you're getting 15 miles per gallon. So it makes sense. Now, one downside here is, notice these labels. They're pretty cruddy, in my opinion. And so we can do better. Now, one trick is we instead of just listing the variable, we say Columbine and then put the variable. Then it uses the variable name. But this is also a nice trick because we can put several variables in there and then use this function on all of them at the same time. So the Columbine forces that name there, and in the list we can assign it a very specific name, and that's what gets put here. And then we calculate the mean. But notice this isn't miles per gallon, it's the mean miles per gallon. So really, in this Columbine statement, we should relabel that variable to m.mpg. By cylinder, we want the mean, and so this is a much better descriptive summary of our data. So mean miles per gallon by cylinder. Now, we could also do it for several variables at a time. So we're going to aggregate. This is our data. We column combine it so it makes it a data frame or a matrix. We want it by cylinder. And we want the mean. And so this is it. But notice that we forgot to update our labels. So Columbine, we're going to put a cylinder label here, and let's calculate the standard deviation instead of the mean. And so this is the standard deviation for displacement for 4 cylinders, the standard deviation for displacement for 6 cylinders. This is the standard deviation in miles per gallon for 6 cylinders. Okay. Now, the grouping variable doesn't have to just be over one variable. It can be over several. So we're going to use the motor trend cars data set. This is the variable, the data that we're going to analyze. We're going to group it by cylinder and gear. And the way that it groups it, it goes this way. This one first and this one. And you can see that it's ordered by this variable first and then the next one. And we want the mean, right? So this is it. This is the mean displacement for a 4-cylinder with 3 forward gears. This is the mean miles per gallon for a 4-cylinder with 5 forward gears. Now we don't have to just use these built-in functions. You kind of saw a little use of creating our own function, the number of non-missing values in our data set. Let's create a user-defined function called mean.standard deviation. So we're going to create a function. We're going to store it in this variable, and that's what our function is going to be called. And we want to create a vector. That's what the C, concatenate, create a vector. And we want the mean of our data and the standard deviation of our data. We're even going to label them appropriately. And so whatever data comes in here, we're going to do the mean and the standard deviation. So let's use aggregate. Let's only use the miles per gallon as a starting point here. Our grouping variable is cylinder, and we're going to use our built-in function. So it takes miles per gallon only for cylinder 4, runs it through this function, and prints it. Notice I put the label here. So that's what this first piece is. And then since I labeled these, it gets a dot mean and dot standard deviation, which in my opinion is great. And then it does it for each grouping of our group variable. Now we can get as complicated as we want here. So let's use aggregate. Let's do it for 2 variables. We have miles per gallon and engine displacement. Our grouping variables are going to be cylinder and gear, remembering that it orders it this way. And we're going to use our built-in function, mean and standard deviation. So here's our grouping variables that we put here. We have nice labels for them. And it calculates the mean and standard deviation for miles per gallon and the mean and standard deviation for displacement. Notice that we have some NAs. And that says that there's either 0 or 1 observation there, right? Because you can't take the standard deviation unless you have 2. Okay, now let's go on to something called S apply. Now, L apply and S apply, they're really cousins of each other, and they deal with lists or data frames. And so that's what this L stands for. It's a function that's applied over lists. And this is also applied over lists, but it tries to simplify the results that it prints out. That's what my understanding of S apply. So if we say S apply on our data frame, S apply is going to go one variable at a time and calculate the mean. And this is the mean miles per gallon, mean number of cylinders, mean displacement, mean horsepower, and that's for everything in our data set. We user defined functions here. So this is the same. S apply means go over every variable in our data frame. Let's use our built-in function. So now we have the mean, the standard deviation for miles per gallon, the mean, the standard deviation for number of cylinders, etc. And here, so S apply, and this is the function that we created earlier that just counts the number of non-missing observations that we have. And it does it by each variable, and then applies this function. And notice that there's 32 observations, non-missing observations in each. Okay, so since we're at 22 minutes, we're going to stop right here and talk about grouping into class intervals. And this, that'll be all. So see you on the next one.